An exoplanet denser than steel. The Whirlpool Galaxy from JWST. We finally learn where the solar wind comes from, and the ISS is getting Gigabit Internet. All this and more in this week's Space Bites. We know of more than 5,000 exoplanets now, and they come in all kinds of shapes and sizes. Super Jupiters, things with the mass of Earth, orbiting different kinds of stars, but a planet was unveiled this week like nothing we've ever seen. The planet is called TOI 1538b, and it orbits its star every 1.24 days. This is, it seems like a hot Jupiter, right? But it's got about the size of Neptune, but it has 75 times the mass of the Earth. And what that means when you do the math is that it ends up having a density that is more than steel. So there is this object that is the size of Neptune, but is essentially just made of rock and metal that is orbiting around this star every 1.24 days. That's bonkers. Like if you do the math, like if you take Jupiter and you strip away all of the gas and you're left with the rocky core at the heart of Jupiter, it's way more massive than that. It's like almost the entire mass of Saturn. It's hard for me to explain just how, I can't believe how crazy this planet is. And of course, when you hear a planet that is like this, that doesn't fit into any of these neat, tidy boxes that we've got for exoplanets so far, you've got to ask yourself, how did it form? Where did it come from? There's a couple of theories here. One is this idea that planets that get really close to their stars, the Neptunes that get way too close, they are hit by the full blast of the solar wind coming from the star, and this can erode away all of the volatiles and unveil the center core. But again, if the center core is something that's more massive than anything would have been inside Jupiter, it's pretty ridiculous. The other possibility is that there was some kind of catastrophic collision between giant Jupiter-like exoplanets. And this collision, according to the researchers, would have had to have come so fast, the planets would have been having to move at 75 kilometers per second. And so when you sort of think about Earth's orbit around the sun, we're moving at 30 kilometers per second around the sun. So more than double the velocity of Earth's orbital velocity. Then you could get this collision where the rocky material, the metals, still hold together by gravity, but the volatiles are blasted away off into space, and then maybe the solar wind carries them away, and you're just left with this, I don't know, I think like Cybertron? I'm sort of imagining this metal planet. It's crazy, and yet this thing is out there. More information is necessary. The Whirlpool Galaxy, seen by JWST. This is one of my favorite galaxies, the Whirlpool Galaxy, also known as M51. Those in the northern hemisphere, you are probably very familiar with this if you take pictures with a small telescope. It's one of those galaxies that you can take pictures. It's only about 37 million light years away, he says, merely. And yet this galaxy is seen face on, and it's called the Whirlpool Galaxy because it really looks like water is going down the drain of some distant drain hole. And this galaxy gets the JWST treatment. And once again, the difference between JWST and visible light telescopes is that it really reveals the cooler regions, the gas, the dust, and you can see these giant dark red regions, which are the warmer dust. And then you can see the spiral arms, where all of these dense knots and clusters, places where new stars are forming. And yet it sort of swirls down into the middle, the central core of this galaxy. This image of the Whirlpool Galaxy is part of a survey that JWST is doing called FEAST. It's the Feedback in Emerging Extragalactic Star Clusters. It's definitely a backronym. It's not the beginning of each word, the letter for the acronym, but a lot of these other galaxies that you've seen fairly recently are part of that same survey. It's just how the image has been processed that gives it a different look compared to, say, the ones that have that eldritch horror look that I'm so fond of. And then another really fascinating object got the JWST treatment this week, and this is Supernova 1987A. And this is the closest supernova that we have seen in the modern era. The supernova exploded about 168,000 light years away in the Large Magellanic Cloud, and it was observed in 1987, hence the name 1987A. And I remember the news when it came out. Like, this was before my time as a science journalist. I was still in high school at the time, and astronomers around the world were watching this object. And now we've got 40 years of observations of supernova 1987A as this central ring of exploded material is making its way through the shed layers of material from this hot star. And you can see there's like blobs that are getting heated up and glowing brightly. And then at the very center of this image, the gas and the dust is so thick that even JWST can't pierce into it. And astronomers were really hoping to be able to see the central neutron star at the core of this supernova, and they weren't able to see it. And so the question is still, is that neutron star there? Did it turn into a black hole? This is still an unsolved mystery. Is New Horizons running out of funding? One of my favorite missions is NASA's New Horizons spacecraft. This was the mission that gave us the first ever up-close images of Pluto, its giant moon Charon, of the Kuiper-belt object Arrokoth. And the spacecraft is still doing fine. It still has fuel in the tank. If another target or two could be found, it could still reach those targets. It still has a lot of electricity in its RTG, so it can continue making scientific observations. And we talked about how it is still contributing to astronomy, helping make these observations of the darkness of space itself. But we got the word that the ongoing operation of New Horizons is on the chopping block. So according to NASA, they're going to be defunding the mission in September 2024. And the annual cost right now is about $10 million per year, and about $3 million of that is to support the ongoing science operations of the spacecraft. And this is obviously concerning. It's a bit of a puzzle. I mean, there are a lot of missions that are going on, but you've gone to all of the time and expense to send this mission to space. It still has fuel. It could still reach other targets. When Vera Rubin comes online, it could potentially have another place that it could go to, and we could see even more images of different Kuiper belt objects, but it has to be maintained year after year, and the team has to be kept operational, or they're going to move on to different missions and no one's going to be around to do the science. Obviously, the people who are working on the New Horizons mission are concerned and they disagree with the decision. And so there's still time to overturn this. We've got a fairly detailed article about what's going on Universe Today, and the Planetary Society is helping to save the funding for the New Horizons mission. So if this mission is important to you, there are ways that you can get involved and try to help save it. Every week we do a vote in our community tab where you get to tell us what was your favorite of the stories that we covered this week. And the big one, the clear winner, was India lands on the moon with 63% of the vote. And like, no surprise to me, congratulations to India for its accomplishment, and obviously you were all as excited to see someone finally land at the South Pole of the moon. Now, if you want to participate in the upcoming votes, make sure you subscribe to the channel, and then the poll will appear in the community tab. When you're scrolling on your phone, you'll see the vote. Quickly vote, and that will help us get more information for next week, and we can celebrate what was the winning story. Could we use pulsars to detect individual supermassive black holes? There are several gravitational wave observatories here on Earth now, with LIGO, there's Kagra, there's Virgo, and each new gravitational wave observatory adds to the overall capabilities of the network. But they're really designed to be able to see merging stellar mass black holes, things with dozens of times the mass of the sun, not see the merging supermassive black holes. They have wavelengths that are just too long. But this year, astronomers used the Pulsar Timing Array, which is 67 individual pulsars, and they looked at 15 years of data, and they were able to detect the background gravitational wave noise of all of the supermassive black holes that are merging across the universe. So they couldn't pick out any individual merger, but they could just detect the background waves. It's like looking at the ocean and just seeing the waves on the ocean and not knowing sort of which wind contributed to which waves. But the question is, like, could we detect an individual merging pair of supermassive black holes using this network of pulsars? According to astronomers, the answer is Maybe, eventually. In a recent study, astronomers looked at what it might take to be able to detect specific merging supermassive black holes. And they simulated if you had 12 pulsars in a very specific grid near to us, that you knew the distances to those pulsars perfectly, and you knew the timing of those pulsars, you could theoretically be able to use those to pin down individual merging supermassive black holes. Now, we don't have that network of pulsars. We don't have a way to measure the distances to those pulsars perfectly. It could theoretically be possible with the Very Large Baseline Array, but there is the new Next Generation Array, which is this giant North America-sized version of the Very Large Array, which is a big array of radio telescopes. And that something like that could be used to position these pulsars and measure their timing. And maybe we could make those detections using pulsars before they're actually detected using things like upgraded versions of LIGO, the gravitational wave observatories here on Earth. We finally know where the solar wind is coming from. The solar wind is this stream of charged particles that is coming from the sun. It is constant, ever present, and it blows out this bubble of material around the sun. And then this bubble interacts with the other bubbles of all of the other stars out there across the galaxy. You get this interstellar medium between the stars. And there's a region where the sun's bubble blows out, and then it's no longer strong enough to overcome the combined force of all of the solar wind from all the other stars in the galaxy, and that sort of defines, in some circles, the limit of part of the solar system. But where does the solar wind come from? Well, it's been detected since 1959 directly with satellites, but we've never been able to find the actual source of the solar wind. Now, there are a bunch of things that are contributing to the solar wind. You, of course, have the flares and the giant mega flares that come off of the sun, and these can cause coronal mass ejections. They can cause very large auroras to happen here on Earth. And astronomers have more recently detected what they call nanoflares, and these are much smaller flares that are much common on the surface of the sun. And it's believed that maybe these are the source of the corona, which is this outer atmosphere of the sun that is millions of degrees and has been another mystery in solar astronomy. And now it's starting to look like it's these nanoflares on the sun that are heating up the corona, but they don't produce enough material to be the source of the solar wind. But now we've got multiple spacecraft that are getting closer and closer to the sun, and the European Space Agency NASA mission Solar Orbiter has gotten close enough that it's been able to detect these tiny little jets appearing in the sun's corona, and it appears that these picoflares are the source of the sun's solar wind. They only last for a very short period of time, and they blast out material at 100 kilometers per second. And that matches the kinds of speed that the constant solar wind is producing. So it might be that now astronomers have found the source of the solar wind, one of these long-standing mysteries in solar astronomy. And the Parker Solar Probe and Solar Orbiter they've just begun. Okay, well, fine. They've been around for several years, but they still haven't reached their closest point where they're going to get the most of the science that they're going to do as they get closer and closer to the sun. So stay tuned for even more discoveries coming from those spacecraft. The International Space Station is getting high-speed internet. Now, one of the downsides of being on board the International Space Station is that the internet sucks. And you hear stories about astronauts taking DVDs up to the International Space Station, and they have a big library of movies that they can watch. And in many cases, they've seen the same movie many times because they're limited by the amount of mass they're able to take up to the station. Boy, wouldn't it be great if they could like stream Netflix and things like that? Did I just advertise for Netflix? You're welcome, Netflix. Not sponsored by Netflix. So NASA has built a new component they're going to be adding to the International Space Station. It's called the Integrated LCRD Low Earth Orbit User Modem and Amplifier Terminal, or Illumina-T. This is a fancy telescope and a laser that's pointed at a relay satellite that's up in geostationary orbit. It's called the Laser Communications Relay Demonstration, or LCRD. And so the plan is that the International Space Station will constantly be targeting the relay satellite with this telescope, making sure it has it firmly in the crosshairs, and then it's going to be shooting it with its communications laser to send data back and forth from the relay satellite. And because the relay satellite is in geostationary orbit, the ISS will be able to send its communications back and forth at any point in its orbit. And so this will give the International Space Station 1.2 gigabit per second internet connection throughout its entire orbit. And I felt like making a joke because like that's faster than most people. Like, how come the International Space Station gets gigabit internet before most people? Do you have to go to space to get high-speed internet? Is this how this works now? So I'm sure the astronauts are looking forward to high-speed, reliable internet. Maybe that technology will be used for the rest of us too at some point. If you like the work that we do, bringing you independent space and astronomy news, why don't you consider joining our Patreon? And one of the amazing things about our Patrons, like we have a lot of patrons at this point, so we don't have to take sponsorships here in Space Bites, in our question shows, in our interviews. And like, I would love to talk about some kind of mobile game or self-help app, but no, I wouldn't. I'm glad I don't have to. And this is a way that I can just focus on talking about the science and astronomy, maintaining a high degree of independence and hit you with the minimum number of ads that we can. Of course, like people keep mentioning, yes, I understand. This is an advertisement for our Patreon. The irony is not lost on me, but still, if you want to support the work that we do, if you want to help me hire more journalists, make more videos, release more podcasts, do more deep dives into what's going on in space and astronomy, join our Patreon. Go to patreon.com/universetoday. SpaceX is continuing to test the Super Heavy booster. We talked a couple of weeks ago that they had a test that went for a couple of seconds. Not all of the engines went for the duration. This time they did another test. They were able to ignite all 33 engines and they went for 6 seconds of duration. All but 2 were able to complete the full 6-second firing before they shut down the test. So they're almost there. I mean, I guess that's enough to get you to orbit, probably. The other thing we saw was another test of the water deluge system. This is designed to minimize the impact on the environment, throw an enormous amount of water onto the plume of flames and quench it, as well as decrease the amount of vibration that happens to the launch tower and the rocket itself. And so hopefully when the rocket takes off, this will minimize the environmental effect of Starship as it takes off, you know, the biggest rocket ever flown. So we don't know when the rocket is going to make another orbital launch attempt, but the rumor mill is running and it sounds like September, maybe, which, you know, like a double at 10. So next year, but no, we'll see. September sounds good. Finally, let's give an update on India's mission on the moon. Of course, they are still working hard to do as much science as they can before the lunar night sets in. We got this amazing sequence of images of the Pragyan rover as it is zipping around the base station. This was stitched together by Simon Schmaus on Twitter. He took it from the raw feed of images from India's Space Agency. The Indian Space Agency has announced that they've already detected the presence of sulfur in the regolith, and they had to steer around a fairly large crater near the landing site. So good thing they're able to continue operating the rover, and we've got about another week before it hits night and we lose contact with the rover. And then hopefully it'll wake up again at the end of the lunar night, but no guarantees. And finally, NASA's reconnaissance orbiter has found the Luna 25 crash site. So here's an image before and then after, and you can see the splat on the surface of the moon. So that's where Luna 25 hit. I'm going to rant about New Horizons for a little more, but first I'd like to thank our patrons, Mark Anstis, Joel Yancey, Antonio Lofilara, Dustin Cable, Just Paul Davis, Vlad Shiplin, Jay Dennis, David Giltonad, Modso, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verboff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level, and all of our other supporters on Patreon. I must say, I am really concerned about this potential news that NASA is going to defund the science program for New Horizons. Now this isn't the whole, like, it's not like they're just like turn off the switch and then New Horizons is going to go offline and then we're not going to hear from it again. You know, about $4 million a year is spent to maintain the Voyager spacecraft. So you can imagine them spending some amount of money every year to maintain operations with New Horizons. And if they do find a new target, they'll be able to kind of spin up the science again and send it, and they'll probably be able to come up with some provisional budget. But the team that is constantly thinking about and working with the New Horizons spacecraft, working on all of the data that has come down and is still being distributed to scientists, as well as these other programs like this, searching for the darkness of space, they're going to have to go find other jobs. And it's really hard in science to kind of get the band back together. You've got this team that's worked together. They're a well-oiled machine. They have a way of communicating with each other. And then each person is now not going to have the funding to do work with New Horizons. And so they're going to have to go and join other missions. And then if they do need to do some kind of flyby, then those people are going to have to split their time between some other thing, or maybe new people are going to have to be found. And you just lose this cadence of the science. It's such a small ongoing investment to keep this mission going and to keep the science coming from New Horizons. And when you consider the amount that's being spent on giant missions like the Mars sample return mission, stuff being done for Artemis, it's money they could find around the couch cushions. And so I really hope they do continue on maintaining the science team for New Horizons.